Alrighty, let's go right into part 3 of review for AB Calculus. We're going to do differentials first, and if we have an example of differentials, just want you to separate them and integrate. So if you have dy plus, well, simple 17x dx equals 0, we minus 7x, so we get dy equals negative 7x dx. Integrate that. And when we integrate it, we are going to get y equals negative 7 over 2x squared plus c. Remember to put in the c. There's often an e involved in here where you would have to raise the e, this to the e power. And the constant could come in front because you can do anything to the constant. It's just a constant. And this is differentials. Often question with slope fields where you have to identify the slopes using the differential equation. Derivatives using exponentials. If you have the derivative of e to the x, just remember find the derivative of the exponent. If it's the derivative of e to the x is e to the x, but derivative of e to the 2x, if you have the derivative of e to the 2x, it's going to be 2 to the e to the 2x. The exponent stays the same, but you find the derivative of the exponent and put it in front. If it's not e to the x, we are allowed to use e to the x. E to the x, the derivative of e to the x, the derivative is e to the x because you're supposed to find the natural log and of the base, and the derivative of a to the x is just ln a to the x, given that x is just x. Or if it was a to the 2x, we would just have 2 ln a. Just remember to plug in ln of a, the derivative of the base. You can put ln of e, but ln of e is just 1. That's why we don't put it for e to the x when we find the derivative. Derivative of inverse functions is just pretty simple. You have the inverse function itself is going to be 1 over the derivative of the inverse function. That's it. The derivative of the inverse function. So dx over dy. And now we're going to go into derivatives of inverse trig, which get a little sketchy, but we'll do that. Y and y prime. If you have arc sine, I'm going to denote it as arc sine instead of sine to the negative first. Easier to write it that way. Arc sine x, which is going to be just 1 over 1 minus x squared. And if you want to remember arc cosine x, it's just negative that. Negative 1 over 1 minus x squared. If you have arc tangent x, is going to be just 1 over 1 plus x squared. And if you want to go backwards, and they give you this part, if they give you, for example, dx over 1 plus x squared, and you integrate that, that's just arctangent plus c, of course, because it's an indefinite integral. And often other ones they could test you on, but it's rarely tested on the AB test if you want to know it. Arc cotangent x is negative 1 over 1 plus x squared is just negative arc tangent x, and arc secant x is 1 over the absolute value of x square root x squared minus 1, and negate that to get arc cosecant x. Alright, so just negate that, and let's keep on going. Integrate, you do the opposite. But that is, I think, the end of calculus for AB, and it was a ride. We do still have 5-6 minutes to, if you want to still discuss anything that pops up in my mind within these couple minutes. Maybe slope fields. Maybe if I can cover limits a little bit more. The limit definition probably. Slope fields. Anything you want to know about slope fields is that if you have differential, so if you have x minus y, and that's the differential dy dx, you can't really do it by hand. It's going to be a lot of work, but if they want you to sketch the differential with the given points, all you got to do is plug in those values. So if this is 0, 0, plug in 0, 0, you're going to have 0. That's it. If you have 1, 0, you're going to have 0 minus 1 is going to be negative 1, so you just just draw a little line that looks like negative y equals negative x, because that's a slope of -1. That's it. And you just keep on doing that for all the points. That's a slope field. It just represents all the slopes for a given differential. And I think that's pretty much it for calculus. If you guys are pretty ambitious, you can go to Calc 2 and maybe learn some BC. I might do a BC review video, depending on time. But that's the end of AB, and I hope you guys do well on your exam. Some of you guys are watching this because your exam is tomorrow, the AP exam. Good luck to you. If this is in the future, good luck to you. If you're just ambitious and watching it for fun, hope everything goes well for you. But that's the end of this video, part 3 of my calculus review for AB. The AB test. But that's the end. Thanks for watching, and leave any suggestions down below for any future videos that you want me to do for calculus or anything math in general. But that's the end, and peace out.